We're going to go over several versions of our hyperbola formula in this lesson, but in this video, we're going to specifically focus on hyperbolas that are centered at the origin and that have a transverse axis along the x-axis. And let me just kind of rewind a little bit. When I look at this, what is my transverse axis? My transverse axis is what goes through the center, your two vertices, and your two foci. When you think of ellipse, that was called our major axis. Okay, but now that it's a hyperbola, we're going to call it a transverse axis. And then if you think of ellipse, we had a minor axis. That's called the conjugate axis here. And so it doesn't really exist. Nothing is on there, but that is there. But we do need to focus on that transverse axis, the axis that goes through the two foci, the center, and the two vertices. So I can tell that this is centered at 0, 0, because it's just x squared, y squared. If you have it centered somewhere else, we're going to have an HK, right? So we'll have something in parentheses, something in parentheses. But if I have an H of 0, that's x minus 0, that's x squared. If I have a K of 0, that's y minus 0, that's just y squared. So we don't need that. So when you just see x squared, y squared, that means it's centered at the origin. And then I can tell my transverse axis is the x-axis because this x squared term comes first. Now, more specifically, it's because it is positive, but they always put the positive one first. So whenever your x squared is positive or comes first, that means your transverse axis is the x-axis. So here I don't have major and minor vertices. So my two vertices are negative A0 and A0. My foci is negative C0 and C0. And so you can see that transverse axis right here where it connects the two foci, the two vertices, and then the center in the middle. This formula has changed from when we did ellipse. So you do want to make sure you're using the correct formula for the correct shape. When we have ellipse, we were using b squared plus c squared equals a squared. Now I'm using b squared equals c squared minus a squared. You can see they are very similar, but they are different. So make sure you are using the right formula for the right shape. And so not only on this formula sheet do I tell you that a is the largest, and I also give you this formula here to find the other variable. So on hyperbola, I tell you that a is always first, and I give you that other formula. So make sure you use the correct one based on the shape that you are graphing. And then we have asymptotes in here. So these asymptotes, again, will go through the center. And we're going to have 2 right here. And so that's why it is plus or minus b over a. There is my asymptote here with my negative slope. And then here is my asymptote with my positive slope. We have 2 asymptotes going in there. Okay, so let's try 2 examples based off of this formula here. Example 1 says find the equation of the hyperbola with the center at the origin. I'm going to graph these as I read them. So I'm going to do center at the origin in red. Center is red. One focus at 4, 0. And one vertex at negative 3, 0. So graph the equation. So first thing I need to do is identify what is my transverse axis. Because all of my important points here on the x-axis, that means my transverse axis is the x-axis. So that's what tells me that we are using this version of my formula, x squared over a squared minus y squared over b squared equals 1. So I know my transverse axis, which tells me the version of the formula that I am using. So let's figure out what is our A, B, and C. A is the distance from the center to the vertex. So we are 3 units away. I don't know anything about B, but C is the distance from the center to the focus, which is 4. So let's find B so I can put that into this formula. So we will use our formula here highlighted. B squared equals C squared minus A squared. So don't know B squared. C squared is 16. A squared is 9. So my B squared is 7. So that gives me enough information to do the first thing, find the equation. So I've got x squared over a squared, which will give me 9, minus y squared over my b squared equals 7. And that equals 1. So we have done the first part. We have found the equation. So now the last part is graph the equation. Okay, well, I can go ahead and plot my second focus. If I'm 4 units away to the right, we'll go 4 units away to the left. If my vertex is 3 units to the left, we'll go 3 units to the right. And now I need my b's. We already have b squared. So if I take the square root of that, I can't simplify a prime number. So we get the square root of 7, which doesn't help me graphing. So let's get out our calculator. And the square root of 7 is about 2.6. So from my center, I'm going to go up 1, 2, and roughly a half. And this isn't part of my graph. It's not a vertex. I'm not going to label it B. You can either just put the point or you can label it as your B. So B for this, B for this, or B for box. And then we'll go down 1, 2, and about a half. Right, so we put on that front page that distance is from the center to make the box. We are going to make the box between our B's and our V's. So I'm now going to draw a rough sketch of a box. I'm going to do very small dashed lines. Between my B's and my V's. And you can use big dashed lines if you want, but I use small dashed lines. Let me kind of fix this. This doesn't look accurate. Let's go up a little bit. It looks a little bit better. Okay, this is what guides me to make my asymptotes. So now I will take my ruler and I'm going to go corner to corner through the center, and now I'm going to make big dashed lines for my asymptotes. There's one asymptote. And corner to corner through the center. And now I can draw my graph. Now I'll get out my blue. All we have are these vertexes. This is going to open up and it's going to get closer to these asymptotes. So it's going to open up and get closer. Open up and get closer. So there's one half. I'll do the same thing over here. It opens up and opens up. So kind of a messy looking graph. What is the only part of my graph is what I have graphed in blue. Okay, but we do need all of that. We need the box, we need the B's, we need the F's, we need the C. We definitely need the asymptotes. Now, this question doesn't ask for asymptotes, but just to get some practice with it, my formula is y equals plus or minus b over a. My b, I'm going to keep as square root 7 over my a of 3x. So this is my asymptotes. Okay, it doesn't ask, but let's just get that practice. And if we understand lines enough, that should make sense. The y-intercept is at 0, so that's why we don't have a plus anything. And then slope is rise over run. So we are rising square root 7 and then running a positive 3. Or we are rising square root 7 and running a negative 3. Okay, let's do another example. This one we were given some information and had to find the equation. Now on example 2, I am given the equation and now we have to find several things. So we need the center, the transverse axis, vertices, foci, and asymptotes this time. So I need 5 things. And then we'll graph it. Well, right off the bat, I do know the center because it's just x squared, y squared. That makes the center 0, 0. I also know the transverse axis. The transverse axis is the x-axis. And I know that not because of the 16, but because x squared is first. So even if this 16 and 9 were switched, it would still be an x-axis for the transverse axis. Okay, now we need vertices, foci, and asymptote. And for that, I need my A, B, and C. So let's identify A, B, and C. With these, it's always going to be x squared and b squared. They're never going to change. So here is my a squared. So a is 4. And this is my b squared. So b is 3. So I have enough information now to find the vertices and the asymptote, but I need C for my foci. So let's go ahead and find C. And so to do that, we will use b squared equals c squared minus a squared. B squared's 9. Don't know C. Minus 16. Let's add that 16 over. And we get 25 equals C squared. So therefore, C is 5. Now I have the information I need. I'm going to write vertices, foci, and asymptotes. Okay. If you have your spiral opened up, you can look on that left page, and we have all of that information right here. My vertices are negative a comma 0 and a comma 0. So we have negative 4, 0, and 4, 0. My foci are negative C0 and C0. So negative 5, 0, and 5, 0. And then my asymptote is y equals plus or minus b over ax. So we get y equals plus or minus b is 3 A is 4x. Those are the 5 pieces of information it needed. So now let's graph it. So we'll start with the center, and I'm going to put that in red. There's my C for center. I'll go ahead and do my foci since I know the transverse axis is the X. All of these need to be on the X. I'm going to go 5 to the left and 5 to the right. I'm going to go ahead and do my B since I have my red out. I'm going to go 3 up for my B and 3 down for my B. And then I'll get my blue and I'll plot my vertices. Okay, so now between my B's and my B's, I need to make a box. And I like to make this with little dashed lines so it doesn't stick out too much. Okay, so there's my little box. And now I'll draw in my asymptotes going from corner to corner through the center. Go the other diagonal. Okay, so I make those with bigger dashed lines, not super important, but whatever. And now we'll go from our vertexes and start going and hugging those asymptotes. So those asymptotes are important to help guide how wide or narrow that is. Okay. Now we have a bonus question down at the bottom, and it says, what is the constant distance difference? Not hard to say. What is the constant distance difference from the two foci at any point on that hyperbola? So if I put any point on this hyperbola and I connect my F for that, I connect that point to one F and to the other. When I subtract, we should get plus or minus 2a. Now, I don't really care about the plus or minus, it's what's that value, right? So if it is plus or minus 2a, and this one, what was my value for a? It was 4. And so we get plus or minus 8. So no matter where I put a point, and if I put a point here and subtract this distance from this distance, we get 8, or any point anywhere on this graph. So those foci, not important for graphing, but they do have a unique kind of characteristic about them.